I did my project on the Fukushima Daiichi nuclear disaster in 2011 in Japan. This disaster was a wake-up call both for Japan and the global nuclear community. Currently, Japan depends on imports for approximately 90% of their energy requirements. However, back in 2011, prior to the nuclear disaster, Japan was working on increasing their energy independence and was generating approximately 30% of their electricity needs from nuclear power. However, post-disaster, this number has dropped to around 2% as of 2016, although the use of nuclear power is steadily increasing again. The specific plant in question is the Fukushima Daiichi nuclear plant, which is located about 250 kilometers north of Tokyo along the coast. The plant was first commissioned in 1971, with the first reactor being built in 1976. The plant itself consisted of 6 reactors, although only 4 of these reactors were involved in the nuclear disaster. The capacity of the plant was 4,696 megawatts, and the reactors themselves were boiling water reactors, which is different from a lot of nuclear reactors around the world. The plant itself was constructed and operated by Tokyo Electric Power Company. This specific nuclear disaster is rather complicated, as it involves 4 of the 6 reactors at the Daiichi plant, and the main events of the fallout occurred over 4 days in March of 2011. Everything started on March 11th, 2011, when a 9.0 magnitude earthquake hit off the northeast coast of mainland Japan, causing the 11 reactors operational at the time to emergency shut off. This is significant because the Daiichi plant was not the only one in operation at the time of the quake, but is the only one that experienced a disaster. The disaster itself was not actually caused by the earthquake, which it was deemed after the incident did not cause any actual damage other than affecting the power supply to the plant. However, the plant did have emergency generators that kicked in to help with residual heat post-shutdown of the nuclear reactor. At the time of the earthquake, only 3 of the 6 reactors were actually running, although 4 of the reactors ended up being involved in the disaster. After the earthquake occurred, within about an hour, a 15-meter tsunami hit the coast and flooded the facility and many other areas, killing thousands of people. However, at the plant, the tsunami flooded generators, which were in the basement level of the facility and were the only backup electricity provided at the site, although there were some battery-operated cooling systems in place. Some of these battery-operated cooling systems did maintain their operations for 20 to 30 hours after the initial tsunami, but they eventually failed and resulted in overheating of the system, which was the cause of the nuclear disaster. Also, on the 11th of March, evacuations were ordered for areas within 2 kilometers of the plant, and then were later extended to 3 kilometers of the plant. On the morning of March 12th, the evacuation boundary was extended to 12 kilometers and later 20 kilometers, and eventually this 20-kilometer boundary became a no-go zone, meaning that no one was allowed to enter it except for official personnel. When the earthquake initially hit, all 3 operational reactors proceeded to go through an emergency shutoff, which basically means that the reactor stopped operating and was no longer working to produce energy and heat, which is how a nuclear reactor works, by producing heat that heats water and creates steam and powers a generator. But even with a shut-off system that shut itself down, the reactor cores do not cool immediately. They continue to produce heat, which is where all the problems with the Daiichi disaster occurred. The first reactor to experience problems was reactor 1, although the order of events that occurred with reactor 1 were very similar to the events that happened with the other reactors. What first happened with reactor 1 is it was the first to explode and leak radiation into the environment. This happened because within the reactor pressure vessel there is water and radioactive nuclear cores that are producing the energy. And when the electricity was cut out from the plant, the cooling systems stopped working, although the heat from the reactor was still operational. So as the reactor continued to heat the liquid, the water, it created steam, and because the cooling system was non-operational, all of this water eventually completely evaporated, leaving the nuclear cores exposed to air, which is extremely dangerous because the water serves as a mechanism to cool down the cores, but with no water, the cores overheated. They eventually melted and broke through the reactor vessel and fell into the containment unit, and the reactor was still producing steam, and as the steam increased, the pressure within the reactor vessel increased, and this got to a point of dangerous levels when a system kicked in to help release some of this steam into a containment unit. This containment unit contained water, which was originally able to uptake a lot of the radioactive material being pumped into it, but eventually it started to boil and heat and create steam again, and could no longer contain all of this radioactive material. In an attempt to keep the reactor from exploding, some of this pressure from the steam was released by an operator into the atmosphere, which is a negative effect of the reaction at the plant. But aside from that, there was also hydrogen within this steam that was released that came from the breakdown of the protective layer around the radioactive cores. Hydrogen is highly flammable when it interacts with oxygen, and theoretically this release of steam, including hydrogen, should have gone out of the plant and not caused any problems within the plant, although the reaction of the hydrogen would have caused a problem outside of the plant regardless. But some of this hydrogen leaked into the reactor building itself, and when it interacted with the oxygen in the reactor building, it caused an explosion. Reactor 3 experienced really similar circumstances to that of what happened in Reactor 1, where hydrogen was eventually released into the reactor building and caused an explosion. This occurred on March 14th. On March 15th, Reactor 4 exploded, also due to hydrogen interaction with oxygen within the reactor building. But this actually occurred because of hydrogen that was released from Reactor 3 and passed through a pipe connecting the two buildings and caused the explosion in Reactor 4, because Reactor 4 was actually not operational during the earthquake or experiencing any of the overheating problems that the other three reactors did. Reactor 2 also experienced an explosion, but this explosion was not quite the same as the other two explosions because this explosion was not a hydrogen explosion. What actually occurred in Reactor 2 is that the wet well suppression pool that gas was released from in Reactor 1, there was no gas release in Reactor 2, and so the buildup of pressure actually created an explosion within this wet well suppression pool. And because this suppression pool was suppressing so many radioactive materials, it had both releases into the atmosphere in the form of steam and vapor, and releases into the ocean because of the water suppressing radioactive materials. Reactor 2 is cited as the main source of most of the released radioactive material into both the soil and the sea from the Fukushima Daiichi disaster. The Daiichi nuclear disaster had negative effects on the environment, society, and the economy of Japan, as well as impacts throughout the globe. It was considered a Level 7 event by the International Nuclear and Radiological Event Scale, which is the highest level on the scale, and it indicates that there was a major release of radioactive material with widespread effects that require planned extensive countermeasures. This is actually the same level as the Chernobyl nuclear disaster. However, the actual harm from Chernobyl versus the Daiichi disasters was very different. At the Daiichi plant itself, almost all of the radioactive monitoring stations were damaged by the tsunami, and there was only one of the 24 active. So all of the numbers associated with the radioactive release of material were estimates. So there was an estimate of about 579 BPQ, which is iodine 131 equivalent, and there were about 570 BPQ of radioactivity released. For reference, this is only about 15% of the radioactivity that was released at Chernobyl. So even though these were both level 7 disasters, they were quite different. The main radioactive material that was released at the Daiichi disaster was iodine 131, which has a half-life of 8 days, and the other was cesium, which has a half-life of 30 years. These half-lives are really important because they had major influence on the cleanup and harm caused by this disaster. Iodine 131 specifically is linked to issues of thyroid cancer because if inhaled or ingested, the iodine 131 concentrates in the thyroid glands and can frequently cause cancer. The interesting thing about this disaster is that the majority of the radioactive material that was released by the end of March, so this was contained pretty quickly. The radiation and nuclear fallout from the nuclear disaster at the Daiichi plant was largely concentrated over Japan, although small amounts of radiation were found along the North American coast, and over 20 countries internationally found elevated levels of radionuclides post-nuclear disaster. As I noted before, radioactive pollutants were released both into the atmosphere and into the oceans, and these pollutants can cause cancer, and there's actually increased health risks for children. The radionuclides in the soil can affect agriculture because of the health risks posed by the radioactive materials and the fact that plants and animals uptake these radioactive nuclides from the surroundings, and this means that farmers can't produce the same things that they previously could, causing an economic impact on farmers and people of the region. Not only was there the potential for harm from the radioactive materials themselves, but there was also harm caused by people being relocated as a result of the disaster. Some people experienced psychosocial and mental health problems post-disaster as a result of being relocated and displaced from their homes. Some experienced PTSD, and within children there was increased hyperactivity and conduct disorders post-disaster. Another major issue with the disaster itself was the fact that there was large amounts of contaminated water that collected on the site, and some of this contaminated water did continue to leak into the ocean, although these leaks were eventually stopped. One of the first things that needed to happen in order to prevent more damage and more negative effects from this nuclear disaster was that the reactors needed to be cooled down with cold water as quickly as possible. So one of the first remedies for the situation was pumping in and spraying in cold water into the reactors. And this was done by both Japanese agencies and authorities and agents from the International Atomic Energy Agency, who not only helped with the immediate disaster cleanup, but also have remained involved in the cleanup over the last 8 years. It is expected that the cleanup and the shutdown of the plant will likely take 3 to 4 decades and will cost tens of billions of dollars. And one of the key steps in the process of cleaning up this site was actually using robots that contained cameras and a bunch of monitoring equipment to go into the reactors and to assess the damage, because even though estimates and predictions were made about what exactly happened and how terribly damaged each of these reactors was, they didn't actually know until they sent in robots to go and check, because obviously no person was able to go in to these reactors to see the damage. But with the help of the information gathered by these robots, the IAEA, Japanese authorities, and other nuclear agencies helping in the disaster relief and cleanup are better able to assess the damage and deal with the problems. To this day, and for a very extended period of time, there will be extensive monitoring and reporting of the results to both scientific agencies, government agencies, and the public about the levels of radioactive material in the plant itself, around the plant, and in areas that are going to affect the community. Another interesting thing that is a result of this disaster is that field monitoring activities are being performed all over this area of Japan. And while these monitoring activities are very helpful, they aren't completely, absolutely necessary at this point to the level that they're being conducted at, but they're being conducted at this level because they're a great way to teach and practice the skills for monitoring radioactive materials in these areas and prepare for possible future disasters. Another really interesting result of the disaster was that the IAEA was able to pass a nuclear safety action plan, and this basically, along with many other results of the disaster, helped increase safety precautions and set new standards for nuclear operations. The specific solutions at the site included filtration of water that had collected on the site in order to remove all of the contaminants, although tritium is not able to be removed from water, so it was either collected or dispersed in very low quantities back into the ocean. The dikes that surround the plant have been reinforced against another tsunami, and the spent fuels are being very carefully removed from the reactors after adding lots of cooling water to help ease the situation immediately. In terms of the radioactive materials that escaped into the atmosphere, most of them went back onto land. The most concentrated of this was at the site itself, which makes sense because this is where the explosions occurred. So immediately following the disaster, crews were sent in to cover the grounds of the site, either with concrete or with resin, to help keep the radioactive dust from spreading and to make it safe for people to be around it. As I said, the half-life of iodine-131 is 8 days, so this obviously was removed from the area pretty quickly and the easiest solution was to keep people out of the area, which is exactly what the Japanese government did. And they were actually overly cautious in this and kept people out for longer periods of time, which I personally think was probably a good decision because it may have prevented a lot of adverse health effects from the disaster. But even after this occurred, a lot of contaminated soil and vegetation was collected and removed from the areas outside of the site and were then properly destroyed of. And in terms of the health risks from the radioactive material, there is continued monitoring and screening for thyroid cancer and other health problems, and there's extensive monitoring of the radioactive materials in the soil and the water, both in and around the facility. So from the Fukushima Daiichi nuclear disaster, there were a fair number of lessons learned. Luckily, this disaster did not cause as much harm as it most certainly could have, but it was still a nuclear disaster that is going to take a very long time to clean up. So one big takeaway is something that we've already known, in that nuclear power production is extremely dangerous, and one of the key aspects to decreasing the danger here is to have clear safety procedures and disaster plans available and implemented at different nuclear facilities. Despite the dangers of nuclear, it is still a relatively clean source of energy, and Japan has gone back to using nuclear and is actually increasing their nuclear use because it allows them to be self-sufficient energy-wise. And despite the dangers there, they're improving their standards and are hoping to avoid future disasters. And I would assume that they have learned a lot from this disaster, as has the general global nuclear community. One key takeaway is that despite both Chernobyl and the Daiichi disasters being classified as level 7 disasters, the Daiichi disaster was significantly less harmful than the Chernobyl disaster, and the two can be compared to take lessons away from each of them. But the overarching lesson from this entire disaster was that better planning and arrangements of backup systems could have been in place to prevent disasters in this case, and should be in place to prevent future disasters. Thank you for listening. Please let me know if you have any questions. I'm happy to try to answer them on the discussion board. The explosion released a large amount of radioactive elements into the atmosphere and caused problems down the line.